Morning. Welcome to our OPW Loading Arm webinar hosted by Peerless. My name is Greg Bayerl, and I'm excited to introduce this session where we'll explore how OPW loading arms can improve your fluid transfer operations. Joining us today is Bill Burns, OPW Sales Engineering Manager, who will share his expertise on enhancing safety, ergonomics, and efficiency in fluid transfer. Before we begin, I'd like to dive into introducing Peerless. We have been a trusted provider of process components for over 110 years, working with customers to solve complex challenges across a variety of industries. We take pride in delivering solutions that prioritize safety, efficiency, and reliability. There are three facets to Peerless. Our Peerless Process Division, we specialize in supporting manufacturing customers in the chemical, food and beverage, pharmaceutical, power, and other various industries. Our Procore division supports OEM customers, custom equipment engineers, skid builders, EPC firms, and large capital expenditure projects. And then our high temp fabrication division, it machines scientific services for laboratory and medical applications and provides electrical insulators and refractory solutions. We have a vast network of manufacturer partners that support Peerless in our large customer base. We've aligned ourselves with these important partners to ensure our customers get the best products and services for their key applications in their facilities and custom equipment they are building. And now I'll hand it over to Charlie.
Thank you, Greg. Just real quick before we start, one quick housekeeping item to talk about are questions. We want to make this presentation as beneficial as possible for everyone involved, so we encourage questions throughout it. Whether you want the topic expanded on a bit more or have an application-specific question, please do not hesitate to ask. There are a couple different ways you could ask those questions. The first is by clicking the chat icon on the toolbar up top. The chat window should appear to your right if it is not already there, and you can simply drop the question in there. I will be monitoring this chat, and once an opportunity presents itself, I will then ask your question to Bill. Additionally, you can raise your hand. Again, once the opportunity allows itself, I will then give you the power to unmute yourself. Everyone now should be muted. And then once you do have the power to unmute yourself, the mute button should turn from gray to black, and then you can unmute yourself to ask your question directly to Bill. If you don't get a chance to ask your question during the presentation or think of a question you would have liked to ask, don't worry. There will be an opportunity at the very end for any additional questions. Now, without any further ado, I will turn it over to Bill, and we can get started. Thank you again for joining us.
All right, I'm going to share my screen. Let me know when you can see it. All good?
We can see it.
Okay. So, yeah, today we're going to talk about loading arms and quick and dry disconnect fittings. To give you an overview of what OPW does, we're into safely handling hazardous fluids. So that encompasses loading arms, swivel joints used in a whole host of industrial applications, and connections, quick connects and dry disconnects, and some process-related products, most notably our VisiFlow site flow indicator, which is inline site flow indication. But I'm going to start with a lot of pictures of to look at today, and try to cover a lot of photos within 30 minutes. But first, I mean, what is a loading arm? It's a glorified nozzle to load a rail car, or a tank truck, or a drum, or a tote. It's a combination of pipe, swivels, a counterbalance mechanism, sometimes some hose, and then what other accessories are needed for the application, whether it's a special valve, a fitting, vapor recovery attachment. Why would you want to use a loading arm versus a hose? So there's a couple of reasons why, but it's mostly geared around efficiency, safety, and ergonomics. Okay. When you are, loading a rail car or tank truck, you're starting from point A to point B. There's a distance that you have to span, and that distance can be heavy with hose. So we try to develop a easily accessible counterbalance system that hopefully one operator could handle and make the operation a lot more efficient, reduce fatigue, and prevent any physical strain or injury that could be associated with that. We also designed it to accommodate on the front end what other than the pipe and swivels and a counterbalance, what else do we need on there? It could be a vapor attachment as shown in this photo. It could be some specialty valves, actuated valves. It could be a dry disconnect fitting and things of the like. Another reason is speed and efficiency. It's a lot easier to deploy a loading arm out to a tank truck or a rail car or a tote when it's balanced. And it's easier to store when you're done using it. And it's really, really suitable and has, a lot of advantage when we get into, larger sizes. So, a lot of loading arms are going to be 3-inch. Sometimes we do 4 inches up to 6-inch. Sometimes we even do 8-inch, but, a 4 and a 6-inch hose is going to be pretty heavy when you're bringing it out to a truck or a rail car. So this is a system that we see a lot. This is not a loading arm; it's a hose at a chemical plant. If you kind of look at that and just envision the operator working on that, working with that, he's got probably a 15-foot hose length, and on the end of it, he's got probably about 40 to 50 pounds of valving on the end. So, when that operator's opening up or connecting to a rail car or a tank truck, he's got to wrestle with that weight on it. And then if you think of weather we're having right now, some of these trucks might have snow and ice on there. Having something that's balanced and contained adds a lot of value. The other reason folks use loading arms would be the reliability of them. Okay, so the average life of a loading arm, depending on the service and how well it can be maintained, is 15 to 25, sometimes even older than that. I've seen loading arms that are 30 years old that we're still supporting. And that's another consideration when you're designing it, when we're, designing it with you. We want to make sure that there's going to be spare parts available, 5, 10, 20 years down the line. And then we're also available if we need to tweak a design in the future, say the application has changed. We kind of try to design it for future consideration of some modifications. Another point is failure mode. A lot of loading arms have hose on there, but when a hose does fail, it could be catastrophic. When a loading arm fails, it's not great, but it can be contained. We have swivel joints that have leak detection ports in there. So if you get a leak, you could contain it until you could schedule the maintenance to repair the failed unit. So, but this is our goal here. This is an LPG loading application, but they're loading through 2 lines. But ideally, we want something that is balanced. The operator could lower that down. The spring is going to contain everything. They're going to make their connection. When they're done loading, they're going to be able to take that system back, raise it up without any effort, and then bring it back to the loading rack. Why are we replacing hose for bottom loading? This is a photo of rail unloading. Okay, a lot of folks don't think of arms for this, but folks are offloading rail cars all the time, and hoses can get run over. There's a lot of abrasion when you're dragging them around, but more importantly, there's a tight little area underneath the rail car where an operator's got to adapt some special fittings to the rail car And then when they're carrying a hose with it and they got like a 3-foot envelope underneath the car, it can get, it's an area where somebody can get injured and tweak something. So tight confined spaces, we'd like to, help with that. So here's kind of a before and after picture of a bottom rail unloader. This is a heat sensitive product where the hose was steam traced, so it was real heavy. They had to kind of operate it with a chain and hoist. So we replaced it with a counterbalance system with steam tracing on the arm. And then they're able to, not drag anything around. Everything's contained within the spring balance here. And then they connect to the rail car. Okay, here's some photos of different applications. Looks like the same site, but they're actually 2 different applications. But we're having that arm balanced, scissor, and you think of this area under here, this is all balanced. Nobody's lifting that when they're making that connection there. Same here. They have to adapt to this rail car outlet, but they got this system kind of balancing whatever we have outboard there rather than dragging a hose and 15, 20 pounds of fittings that are attached to it. Okay. So how do we do this? It sounds easy, looks kind of easy, but there's a lot involved in the loading arm design. And if you have applications at your sites, if any of these photos, spark an interest in you, it can get pretty involved in designing it. So, but the first thing we look at is the safety and ergonomics. What are we doing? Are we adding value here? And we look at, how far do we have to go? Is there misspotting of the vehicles? Do we have different types of vehicles? It used to be this rail and truck. Now we see a lot of ISO containers that are shipping globally. Do we have the right size for the flow? A lot of it's going to be dictated by the connection on the transport, but sometimes we might have to increase the size of part of the arm so it could reach a certain distance. So, and then of course, like anything, the right material construction, is it compatible with the fluid? Do we have the right seals? And then we kind of look at the area. Okay, what's in the way? I have a handrail here. A lot of sites are, 50, 60, 70 years old. There's a lot of aged lines there that, could be removed. Sometimes we try to design around it. So we look for the best location, work around whatever obstacles there are, and try to design the appropriate system. And then we, ask the question about what else needs to be on here. Are we making a special connection there? Do we need to consider vapor recovery? Is it a flammable material? So is it need to be intrinsically safe? We have options. All of our swivel joints have a option to be internally grounded, so we don't have to worry about bonding straps or anything like that. So, but a couple of photos to look at here. On the left, this is a pressure car loading application. It's showing the operator being able to operate 2 arms of product in a vapor and taking it back to the rack after he's loading. Out here on the right is a chocolate loading application where they have tanker trucks with various hatch openings. I don't know if you could see the gangway here, but it slides along this track. And then this arm is located in the center, so it could kind of reach a lot of different variations of distances it needs to hit for loading. But this is what we look at. We have a design form, that I use at least in my mind, or bring to a site visit, or if we can't arrange for a site visit, we'll ask you to kind of pull out some of this information. But where's your piping? How is it oriented? Where are we attaching the arm? What's the distance it needs to go? How much lateral misspotting it is. So this is for top loading rail and tank truck. This is for bottom unloading rail cars. Have a section here that we'll talk about the material construction, the seals needed, and then everything's made to B31.3, but if you have additional test requirements, we could take a look at that. So this is these are the templates that we use to design a system. And in addition to making the site visit and talking to the operators and seeing how we could make the loading application better. So there's a bunch of different types of loading. This is open dome loading. So this is a general service rail car, but it would look the same for a tank truck, where we're just opening a hatch and putting the loading arm in, okay? And then there's some applications. This is also a general service car, but they have that open hatch, and then they have a dip tube dome. Here on the left, the car was riding with our dry disconnects on there. So we have hoses on the end of loading arms with the mating fitting. So when they break that connection, there's no product loss. But if the car doesn't have it, which is most common, you could make adaptations to it. And that's what you see here. You know, we connected to the dip tube with a little spool piece, put a set of dry disconnects on there. But you could just also use a cam lock or, you know, rotating flange, whatever the site wants to use and whatever the rail cars are set up for. This is a pressure car, so this would be materials, you know, like propane, butane, anhydrous ammonia, chlorine is loaded in these types of cars or unloaded in these types of cars. So we're making a tight connection to the rail car. So this arm is on the right here is the product connection. We have a loading arm connecting to the vapor connection. This vapor connection, depending on if the car comes in backwards, it might be here. So we got a design for that. So just some illustrations of what they might look like. In some instances, with highly corrosive materials, sometimes you can't really justify the cost of using an exotic alloy in an arm, although we could build them out of it. But folks might be loading HCl or bleach, and they like the advantages of a loading arm with the swivel joints and the counterbalance mechanism, but the material might not be compatible. So we build a loading arm that could balance a combination of Teflon lined hose and pipe, or both. And here's some kind of illustrations of that. This is a HCl arm, Teflon lined hose feed in the product, Teflon lined pipe here. We have another jumper section around the counterbalance system, Teflon lined pipe and elbows here, valve on the end. And that's, that's how we address the highly corrosive applications. This is a bleach loading arm, simple design. Basically, the hose is being balanced by this arm. We build a cradle there to support that hose when it's loading, but then this will be balanced and retract up when they're done loading. Then there's bottom loading. Here's a low profile, what we call a boom style arm, but this will scissor out to either the belly or the rear of a tank truck or a rail car. This is outfitted with a dry disconnect on the end. Oftentimes you might have a valve or a cam lock. But this is a petroleum bottom loading application to where they're loading a truck with multiple compartments. So all these 5 arms might be loading at the same time. So we design it to where they can cross over each other and store and interact with each other while they're, loading the tank truck. In a chemical tanker, it's usually one at a time. In a petroleum tanker, it could be multiple at a time. It's another design, an A-frame bottom loader. This is appropriate for loading in the belly of a truck. The advantage of this is it stores nice, like an A, so it takes up less space than, something like this. Just a couple more photos of a truck loader. This top photo shows it loading in the belly of the truck. And sometimes you might be doing both, loading in the belly and then, or unloading from the belly, unloading from the rear. This is what it would look like here. Some rail unloading applications. Again, had some photos earlier. This kind of, gives you an idea of like the fitting arrangement sometimes that we could offer, a little bit more ergonomic. And then then we get into vapor recovery too. So a lot of those rail photos I showed you, there were direct connects. So that would be similar to this. You know, we have a loading arm. This is a simple fixed design, and then we piggyback the vapor hose on there. You can get elaborate and have two arms working simultaneously with a vapor attachment on there. This is two arms, a product arm and a vapor arm that's going to be connecting simultaneously to the vehicle. And then we also offer vapor plates. If you remember the open hatch loading, say you're still loading like that, but you want to recapture vapors, or you just want to cover the hatch, we have a system. This is probably the most common vapor attachment we supply. It'll rotate around here. We could use the bolts on a rail car or a tank truck to tighten it down. Underneath here is a gasket, so it's all sealed. Yeah, better photo of that piggybacked arm, but just to give you an idea, this is the product. This is the vent line, and it's all contained within the arm and balanced within the arm. Two arms here, vapor line here, product loading here, and adapting that rail car with a dry disconnect here. You can't really see it that well. A lot of applications are heat sensitive products. So we could do jacketed arms, steam traced arms. A lot of times folks will electrically heat trace the arm, and then we would want to, insulate it. Right here is a molten sulfur loading arm at a refinery. We got a vapor attachment on here, jacketed arms that are insulated, and then a vent line. This is a rail car loading arm with a custom insulation blanket that is made specific to our drawing with a 3D model. Another tank truck loading. This is actually loading through the bottom connection of a truck. And it's a heat sensitive product that you can't see it, but it's electrically traced. But the insulation blankets are nice and tight and designed not to impede the movement of the arm. We also do arms for implant use, drum and totes, kind of like a mini loading arm. This is a photo of one going through our shop, being tested for, seeing how well it works to hit 4 drums. Here's a couple of field photos. Here in the middle, we had a customer wanting to load 2 rows of totes. So we have a pretty long arm, but this is balanced. They could swing it out here. They could, swing it out here to load this tote. Over here on the right, you can see a kind of mini loading arm. We're not using a counterbalance here, but sometimes we're taking some pipe and some swivels and allowing, this piping to rotate in order to fill a drum or a tote within a short distance. Here, I wanted to point this out to you. Sometimes with the loading arm, you got to have the piping to support the weight of an arm. Oftentimes, that's not an issue. In plant, sometimes it is. So sometimes we'll build a structure. This is just a simple little gusset plate that we anchor to the ground. And you could run your piping here. So you don't have to worry about your piping to support the weight of everything. This particular customer wanted a cam lock here because they wanted to load different products through the same arm. So we outfitted it with a flange cam lock so they could connect, product A, product B, product C. So just to kind of give you some ideas. So that kind of covers the loading arm section. Hopefully, gets you thinking of some applications. We can get into, granular detail or a little bit more detail if you think of an application at your site. But want to give you another high level overview of the quick and dry disconnect fittings that we make. This is an overview on the bottom. Quick connects, we make our cam lock. We have a locking cam lock. We have our hill tap, high pressure, hand tight union. And then we also have a locking quick connect that locks under pressure. And then dry disconnects, these are positive shutoffs from both ends, okay? And we have a few different offerings here. We have the Canva lock, which is a cam and groove style. We have the dry lock, which is a kind of clamshell design. We have the twist lock, which is a quarter turn system. And then we have the Epsilon. So out of all these are all puppeted designs, and I'll show you that here. The Epsilon is a ball valve, so that has an advantage in flow characteristics. So, but you're using quick connects and dry disconnects in various applications. Anytime you have a temporary connection, but we want to select it, for the right application. If it's something you're going to be disconnecting a lot, no big risk of spills, kind of lower pressure, you're probably in the cam and groove fitting area. Sometimes you'll have a product that you're spilling a lot. Maybe you could consider a dry disconnect there. But a lot of applications: implant, fluid transfers, the loading unloading that we showed, and totes, ISO containers. So those are all loading applications. But an overview of the quick connects: we got the cam locks. It's kind of relatively lower pressure, 150 psi for anything above 2-inch, 250 psi up to 2-inch. We have our Hilltap 3TL, which I'll show you. This is like a hammer union, but could handle a lot higher pressure with a tenth of the torque. But we can get to a 4-inch, about 736 psi, 1-inch around 2400 psi. Oftentimes folks are using them in a lot lower applications, but the ability for it to contain a lot of pressure is often desirable. And then we have a locking quick connect that will lock under pressure. We'll talk about that here briefly. And then we have a utility fitting, our stop lock. So this is kind of like a hammer union. It's a little higher pressure than a cam lock. So if you're using a cam lock where you shouldn't be, and it's higher pressure, you might want to use this. A lot of folks would use this for like steam, other utility applications. But wanted to go into the Hilltap. If folks are familiar with, this is kind of like the new quick flange, but rather than a hammer union or a cam lock, our primary seal is based on a metal to metal wedge. So we're not really, concerned about, the gasket and the seal material. It does have an O-ring on there that we want to be compatible, but it's not the primary seal. So, so this allows us to kind of hand tighten it and get real high pressures, but also too, a lot of applications, you might have temperature swings during the cycle of a loading process. A gasket or an O-ring sometimes reacts differently. And the solution typically is to, make that tighter. With this one, this handles pressure differentiation and seal variation a little bit better because it's a metal to metal wedge seal. So here's a couple of field photos on there. This is a rail car loading application. We got big looped handles here to get some good leverage for that hand type fitting. This is a chlorine application. So right here is the fitting out of Hastelloy. So normally when we're here, folks are using either what they call a knock union or a hammer union, and you're kind of beating it every time and deforming it every time you're using it. This is hand tight. This customer wanted a tool tight fitting, so we put wrench flats on there. But this is highly repeatable and reusable, to where a hammer union is going to have to be replaced a lot because in a service like chlorine, you don't want to take anything to chance. The other thing we'll replace with this is in flanges. And if you could think of, unbolting a flange in a flange every time you're loading a rail car or unloading a rail car, that's where the advantage is there. So it's a lot safer.
Hey, Bill,
locking,
just just real quick, we are at that 30-minute mark, so
Okay.
just be cognizant of that as we're going through these last few slides, okay?
Yep, this is our lock and quick connect. So if there's interest in that, we could kind of elaborate a little bit more, but this will lock under pressure. Okay, so if you have worried about opening up a cam lock under pressure, this is a solution you might look at. Okay, then I'm going to cover dry disconnects. We talked about them a little bit here, but we have a couple of different products. The cam lock, which is a valved cam lock, so it connects like a cam and groove fitting, but they have valves on both ends. Product's been around about 60 years. Here's a quick little video of how it operates. But you connect it, you open the valve, and then you're at flow. And then to disconnect it, you close the valve and you open the cam arms, and you're done. We have a version with it that's a lot drier, has a flat poppet. I'm going to kind of burn through these. This is previous photo I showed you, but this is it on a rail car. Implant used for blending. There's another blending application, implant use. But you're saving product from spilling and buckets in the plant. The dry lock is similar to the cam lock. It's a puppeted design. This video is a little long, but it uses a clamshell design. It's oversized, so we have a little bit better flow. And then we got some safety interlocks. You got to do a couple of sequences of things in order to open it. This is what it looks like internally. A seal and 2 O-rings. The advantage of this is it's a little bit more rugged, and it's pretty easy to repair because we use standard O-rings. Here it is on a rail car application. The cars were riding with the adapter on there, but you could adapt your rail car to have a set of these on there. Sulfuric acid is a common application where I use this. And then our Epsilon. This is kind of our highest and driest dry disconnect, but you would use this where you can't really tolerate any product loss, but it also has really good flow characteristics. There's no flow restriction in this. So some materials where you might have, it might be, too viscous for a puppeted design. You could look at this one. This has higher pressure rating. So it opens itself up to a lot of different applications. But this is a good slide just to show you how much quicker it is to our puppeted designs. A 2-inch valved Epsilon is going to be, a 3-inch puppeted design is 65% slower. If you're comparing a 2-inch poppet to a 2-inch Epsilon design, it's almost 200% slower for a 2-inch puppeted design. So in some cases, puppeted designs, we sell a lot of them. It's not that big of a deal. Sometimes you're just talking about, a pound or two of pressure drop. But if you got a thick material, it'll add up over time. That's where folks would use this. Okay. I know we're getting close in time here. So here's some quick animation. How it works. A lot of different safety locks, interlocks here. You can't connect it until you can't open it until you're connected. And then there's a couple of other sequences that you have to do. Got to open this coupler side first, then it'll allow you to open up the adapter side. And then you reverse that sequence to close it. Here's a couple of field photos, not great, but one of the big areas that we use this is in the pharma markets, glycol transfer in a plant. This is a looped glycol system at a plant. They're connecting 2 ends to the hose to a tank here. This is where the Epsilon is there. But if you could think about being in like a clean room environment, all suited up, you get a drop of glycol on the floor, it's slippery. It's something that you kind of want to avoid. So that's where we use a lot of it. I use a lot in the silicone industry just because of its flow characteristics. And then anywhere that you can't tolerate like a milliliter of product loss, this is what you want to look at. Okay. And then we have our twist lock. We're running kind of close on time here, but this is a quarter turn. The advantage of this is it doesn't have a valve handle. Okay. So it's a little bit more ergonomic. And it's interchangeable with other manufacturers out there. They're all European based, but you might hear somebody talk about a Toto or a Mantech. This is our version of that. And it's also made in Europe. So here it is on a sulfuric acid tank truck loading application. Here it is on a LPG application. So it does have a little higher pressure, so we could use it for some compressed liquids. And then lastly, this is not a dry disconnect, but this is used on loading hoses and loading arms, but it's a safety breakaway. It's an engineered break point, okay? If you ever have a pull away when somebody's loading a truck or a rail car, they don't disconnect, they pull away. This is the break point that will separate, and you can reset it in the field. Here it is on a loading arm. So if that rail car were to take off, rather than tearing everything down like you see in this photo here, this will separate here and saves you some money. It's a little insurance policy for for your loading rack. So, but that concludes it. I appreciate your time here. Do you have any questions?
Thanks, Bill. That was very good and very in depth. It does look like we have a question.
Okay.
All right. How does the design of the loading arm minimize risks associated with vapor emissions and spills, particularly in confined or hazardous environments?
Repeat that question again. I apologize.
So, nope, all good. How did the design of the loading arm minimize risks associated with vapor emissions and spills, particularly in confined or hazardous environments?
Okay, so yeah, we take that all into consideration when we're designing something. So if we need to design something that requires vapor recovery, we're either going to see if the rail car is equipped, to have a direct connection on there to where we can maybe incorporate a dry disconnect. And if that is not the case, we can provide a vapor attachment like the vapor plates and then incorporate that into the design to where you can recapture the vapors. And then you have to, look at what you're doing with the vapors. And that's more process related, but mechanically, that's what we're looking at there. We're going to incorporate that into the design of the system. Any other questions?
Thank you for that. Looks like we got one more. What are the key factors to consider when choosing the materials for loading arms in highly corrosive applications, such as those involving HCl or bleach?
Yeah. So, well, when we're designing a loading arm for any application, the first thing we look at is the compatibility specific to HCl and bleach. If you recall the bypass arms, which was basically using the advantage of the arm in a counterbalance system, but we're using it to carry a combination of Teflon lined hose or pipe, something that's compatible with the HCl or the bleach. So the arm in this case is not wetted, but it's balancing and supporting the wetted flow path that is going to be compatible with HCl or bleach.
Perfect. Thank you. Another one. Can you elaborate on how ergonomic and environmental considerations influence the deployment and storage of loading arms compared to traditional hose systems?
Okay. Yeah, that's a great question, and it's really what we try to do, but a lot of it is going to be site specific, right? So what I like to do and what we like to do is, kind of make the site visit. Either, if not, we could get some photos there to see where we're going to mount the arm, but also envision the operator, how he's going to access the arm. And ideally, it'll be like some of those photos where that arm can just be accessible, the end of it, and they can walk it out to the rail car or tank truck from the rack without balancing, without lifting anything. Some cases, that's not the case. And it's just based on the site. You might have obstructions in there. We try to accommodate around it. Sometimes folks will want the arms mounted higher to where there's going to be a lot more clearance for the arms for traffic. But the trade-off is, the access to the arm. It might be a couple more steps that operator has to take. So that's on a case-by-case basis, but we obviously take that into consideration, have that discussion when we're designing a system. So.
Awesome. Thank you.
Sure.
We'll give it another few seconds here to see if there's any other questions that come through. Doesn't look like anything is coming through, so I think that that will conclude it. Greg, I don't know if you want to.
Yeah, I just want to thank everyone for joining us today. Thank you, Bill, for a great presentation. A lot of great information there, and I just wish everyone to have a great day coming up on a great weekend. And if anyone's a Bills fan, go Bills and stay warm.
Go Bills.
Take care, everybody.
Thank you.
All right. Thanks.